How do we multiply powers? Let us investigate. 2 cubed can be written as 2 times 2 times 2 in expanded form. 2 to the power of 4 can be written as 2 times 2 times 2 times 2. So now instead of writing it in expanded form, we can say, okay, 2 is multiplied by itself how many times? 1, 2, 3, 4, 5, 6, 7. 7 times. But that seems like a lot of work. Do you see an easier way? Yes, of course. How did we get the 7? We added the 3 and the 4. Now remember, to multiply powers and the bases are the same, we can add the exponents to quickly see how many times that base number has been multiplied by itself. So let's use algebra to generalize the rule. So any number a to the power of m times, but it must also be a because the base must be the same, to the power of n is therefore equal to a to the power of m plus n. And that's our law for the multiplication of powers. So is the following correct or incorrect? 2, remember that was an m and an n, 2 to the power of 3 times 3 to the power of 2 is 6 to the power of 5? No, the bases are not the same. If you're going to expand this is going to be 2 times 2 times 2. And then the 3 will be 3 times 3. So the base is not even 6. And you cannot add the exponents because this means it's 6 times itself. 5 times. So the base must be the same and you have to multiply. Even this one, where students make a mistake. They will say 2 to the power of 3 plus 2 to the power of 4 is 2 to the power of 7 or even 4 to the power of 7, which is wrong because in this case, yes, the bases are the same, but you have to multiply. What happens if the bases are negative? Well, look at number A. We've got negative 1 to the power of 3, which means it's negative 1 times itself 3 times, and the answer is negative. When it's negative 1 to the power of 4, the answer is positive because a negative times a negative is a positive and a negative times a negative is a positive. So what do you notice? That's very clever. As soon as the exponent of a negative base is an odd number, then the answer will be negative. And if the exponent is an even number, then the answer will be positive. So for example, let's look at number F here, negative to the power 2 to the power of 3. We know 2 to the power of 3 is 8, and it will be negative since the exponent is an odd number. If we multiply powers with different bases, we have to keep the different bases separate. And we can then add all the exponents of the powers with the same base. So for example, look at number A. So we are going to first multiply 2 to the power of 2 and 2 to the power of 4. That will give me 2 to the power of 6. And then we'll multiply 3 to the power of 3 and 3 to the power of 8, which will give me 3 to the power of 11. And then you stop. You can't do anything else because the bases are different. Also look at the example in B. It's the same kind of thing. Find all the bases. You can use the same color. For example, all the 3's in one color, all the 5 to the powers in another color, and that will make it easier for yourself. Now let's put everything together. 6m to the power of 2 times 3m to the power of 3. Well, we can use the commutative and the associative properties here because it's all multiplication. Let's multiply the 6 by the 3 and then we'll multiply the m squared times the m to the power of 3. We can get an answer for 6 times 3, that's 18, but we can just write this shorter. The bases are the same, so we'll just add the exponents and the answer will be m to the power of 5. So that will give me a final answer of 18 m to the power of 5. Let's say we had negative 6 m to the power of 2 times negative 3 m to the power of 3. Then the negative times the negative will give me a positive.